3I/Atlas. On October 5th, something fast, incredibly fast, streaked across the Martian sky. Amateur astrophotographer Stephen Burns wasn't looking for anything extraordinary. He was simply processing NASA's publicly available raw images from the Perseverance rover. That night, the rover had been instructed to scan the starfield. What Burns found in that data would ignite one of the strangest debates in modern astronomy. He created a 9-minute time lapse, compressing the images into a smooth animation. Stars drifted slowly, predictably, their motion a byproduct of Mars' rotation. But one streak cut across the frame at an angle that made no sense. It wasn't a background star. It wasn't a cosmic ray artifact. It was moving fast. 60 kilometers per second. Faster than almost anything in the solar system. For comparison, Earth orbits the Sun at 30 kilometers per second. Only the Parker Solar Probe, skimming the Sun itself, ever reaches 192 kilometers per second. But this thing, later catalogued as 3I/Atlas, was maintaining a blistering 60 kilometers per second far from any planetary gravity assist. Burns posted his animation online. Within hours, the amateur astronomy forums exploded. A German user going by, Nachtaf, claimed he saw not one object, but multiple, moving at different velocities. Another user, Alexander Fum, highlighted a brief green flash at the 3-second mark of Burns's video. Green light in space is rare. It usually comes from excited oxygen, or the molecule dicarbon, C2. But spectroscopic analysis from ESO's Very Large Telescope had already shown that 3I/Atlas was chain depleted, almost no dicarbon. By every rule of comet physics, it shouldn't be glowing green at all. And yet there it was. A diffuse, localized emerald flash in the Martian sky. The multiples. When the starfield in Burns's animation was stabilized and Mars's rotation subtracted, at least 2 additional points of light appeared moving in parallel. Artifacts? Asteroids? Fragments? Nobody could tell. What they did know was that NASA had aimed almost every major Mars orbiter at 3I/Atlas on October 2nd and 3rd, the closest any spacecraft had ever come to an interstellar object. The high-rise camera aboard Mars Reconnaissance Orbiter, capable of resolving 30 centimeters per pixel on the Martian surface, was pointed at the object. At 29 million kilometers away, the resolution would drop to 30 kilometers per pixel, still enough to distinguish a compact nucleus from multiple components. ESA's Trace Gas Orbiter and Mars Express also conducted coordinated observations. And then silence. No images. No data. No raw frames. NASA's official line. Data is being processed. ESA's official line, nothing at all. In the world of space imaging, 24 hours is usually enough to at least preview raw data. We're now far past 48. Publicly, the delay was attributed to processing pipelines and calibration. In reality, researchers whispered about a coordinated hold. Budget disruptions on NASA's side. Unexplained silence on ESA's side. The gap between what should be routine disclosure and what actually happened only fueled speculation. Meanwhile, an independent astrophotographer, Simeon Schmaus, claimed to have spotted 3I/Atlas already on October 1st, before the official observation window. His process frames hinted at a faint, fast-moving object, and a slight deviation from its predicted trajectory. Then he, too, went quiet. The window for observing 3I/Atlas was closing. By late October it would slip behind the Sun, invisible to ground-based and space-based observatories alike. If the multiple objects were real, if the green flash meant something, this was the moment to find out. The WOW signal connection. While the public stared at Perseverance's images, Harvard's Avi Loeb was looking backward. He reconstructed 3I/Atlas's trajectory through time, running the numbers all the way back to August 15, 1977, the night of the famous WOW signal. That night, Ohio State University's Big Ear radio telescope recorded a narrowband signal at 1,420 MHz. The hydrogen line. Strong. Clean. Lasting exactly 72 seconds. Astronomer Jerry Emmons circled the printout in red ink and wrote a single word in the margin. Wow! Loeb's calculation placed 3I/Atlas within a few degrees of the WOW signal's sky coordinates in 1977. The odds of that alignment by chance? 0.6%. To transmit a signal detectable at that distance would require about 1 gigawatt of power, the output of a single nuclear reactor. Not impossible for an interstellar probe. Even the blue shift of the WOW signal matched what you'd expect from an object inbound at 60 kilometers per second. Not perfectly, but close enough to raise eyebrows. Was 3I/Atlas a comet? A fragment of a planet? Or something else? Something sending a ping at the one frequency every radio astronomy civilization would be listening to? Right now, 3I/Atlas is hidden behind the Sun, moving toward its closest approach to our star. When it emerges in November or December, it may confirm every natural explanation. Or it may have done something no comet has ever done. It's producing industrial-grade nickel alloys in space. Its tail points the wrong direction. It's green when it shouldn't be. And it's following a trajectory so perfectly aligned with our planet that the odds are astronomical. Some are calling it the largest interstellar object ever detected. Others are calling it impossible. Loeb is calling it potentially artificial. When it comes back out from behind the Sun, the world will be watching. If we're still allowed to see. It began, as so many cosmic mysteries do, not in a lab or an observatory, but on a laptop, in the dim light of a cluttered home office in Bristol, England. Stephen Burns was not a scientist. Not officially. He was an astrophotographer, the kind of person who spent his nights chasing faint glimmers in the dark, parsing noise from signal, dust from data. He called it listening to the sky with your eyes. That night, October 2nd, he was processing NASA's publicly released raw images from the Perseverance rover. The rover, during its scheduled downtime, occasionally turned its cameras toward the night sky. These were routine calibration sequences, snapshots meant to test star tracking algorithms. But this time, Perseverance had been instructed to observe the stars for a longer window, 9 minutes of continuous imaging. The reason, buried deep in a mission log entry, was simple. Scheduled sky survey during predicted proximity of C/2019 U3, 3I/Atlas. Burns wasn't expecting anything unusual. He'd done this dozens of times before, downloading the images, aligning them, stacking them into a time-lapse. It was tedious work. The kind of patience that only astronomers and monks possess. He sipped his coffee, clicked render, and watched the animation begin. At first, nothing. Just a slow, hypnotic drift of stars across the Martian sky, their steady march caused by the planet's rotation. Then, something cut across the frame. Fast. Too fast. He paused the sequence. Rewound. Advanced frame by frame. There, a faint, sharp streak darting diagonally across the starfield. Not a meteor. Not dust on the lens. It moved. He ran the parallax analysis twice. The numbers didn't make sense. Velocity, roughly 60 kilometers per second. Direction, inconsistent with any known satellite or asteroid path. For comparison, Mars itself orbits the Sun at 24 kilometers per second. Even the fastest artificial objects, the Parker Solar Probe, for instance, only reach triple that speed when literally skimming the Sun. And yet this thing, this pale blur, was maintaining its velocity far from any gravitational boost. Burns blinked. His pulse quickened. He rechecked the timestamps. Then, out of instinct, he did what every modern observer does when faced with the impossible. He posted it online. Within hours, his videos spread through the small but dedicated world of amateur astrophotography. On Reddit, on specialized Discord servers, in private Telegram groups, everywhere that people compared starfield data and spectral anomalies. It was there that a user named Naktaf, a German astrophotographer known for his meticulous calibration threads, made the first bold claim. It's not one object. Look carefully at frames 87 through 122. There are at least 2, maybe 3. He attached an edited version of Burns's time-lapse, stabilized so the stars remained fixed in place. When you did that, the effect was unmistakable. One bright streak, followed half a second later by 2 dimmer, parallel trails, slightly offset in angle. At first, many dismissed it as noise, lens ghosts, compression artifacts. But then another user, Alexander Fum, noticed something else. At 3.0 seconds there's a green flash. Look again. Burns did. At exactly the 3-second mark, a soft emerald pulse illuminated a small section of the frame. It wasn't sharp or pixelated, as cosmic ray hits usually are. It was diffused, as if the light had passed through vapor. A green light, blooming faintly in the Martian night. By morning, message boards were filled with spectral comparisons. Green emissions in space usually come from oxygen, or from dicarbon, a molecule of 2 carbon atoms that glows green when excited by sunlight. Certain comets display this signature when they approach the sun. But there was a problem. Spectroscopic data from the Very Large Telescope in Chile had already classified 3I/Atlas as carbon chain depleted. Virtually no dicarbon at all. By all chemical logic, it shouldn't be glowing green. So what was that flash? Amid the speculation, a handful of professional astronomers joined the threads. One, using the handle at JPL_archive, confirmed that NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and ExoMars Trace Gas Orbiter had all been pointed at 3I/Atlas during that same observation window. Coordinated, high-priority observations. Simultaneous imaging sessions from multiple orbiters. That kind of cross-agency coordination didn't happen often. Something about 3I/Atlas had clearly drawn serious attention. And then came the silence. No new frames from HiRISE. No preview data from ESA. NASA's official feed, usually updated hourly, went still. The only response came from a short, clinical statement. The Mars orbiters have successfully completed their scheduled observations of interstellar object 3I/Atlas. Data processing and calibration are ongoing. No images. No timelines. No details. Within the online community, theories began to spiral. Some believed the agencies were simply cautious, waiting to rule out processing errors before publishing. Others were convinced they were sitting on something bigger. Burns, meanwhile, kept rewatching his animation. The green flash. The multiple streaks. The strange, angular path. Every time he looked, it seemed stranger. He noticed something he hadn't seen before. A faint shadowed haze trailing one of the streaks, like a thin plume. Not straight, but bent, as if it were being steered. He didn't post that one online. He just stared at it for a long time, then closed the program. Outside, the October rain tapped quietly against the window. Inside, in the faint blue light of his monitor, Mars hovered on the screen, silent, red, and impossibly far away. And something beyond it was moving fast. Too fast. The Mars blackout. Silence in science is rarely accidental. When data disappears, or rather, when it fails to appear, it's almost never because of a broken antenna or corrupted file. In the modern age of transparent archives and automated pipelines, information doesn't just vanish. It waits. And waiting is exactly what the astronomy community was doing. 1. The delay. 48 hours had passed since the October 3rd observation of 3I/Atlas, the first time in history that multiple Mars orbiters had been aimed at an interstellar object. In that time, no raw images appeared. No calibration reports. No previews, not even a single grayscale thumbnail. Under normal circumstances, NASA's HiRISE camera aboard the Mars Reconnaissance Orbiter uploads its raw data within a few hours of downlink. ESA's Mars Express and ExoMars Trace Gas Orbiter, TGO, do the same. Their automatic feeds populate the Planetary Science Archive within the day. This time, both archives were frozen. On October 4th, 9:32 Universal Time Coordinated, a single-line message appeared on NASA's internal MRO operations feed. Data under internal review. Calibration ongoing. On ESA's side, there wasn't even that. The pattern. Among planetary scientists, there's an unspoken pattern, one that veterans recognize immediately. When something routine is captured, dust storms, auroras, frost patterns, data floods in instantly. But when something unexpected shows up, a light, a reflection, a strange spectral line, everything slows down. It's not censorship, not exactly. It's containment. The data is pulled from the automated queue. Teams are asked to verify instrument behavior. Additional analyses are ordered. Just to confirm. The review process, which normally lasts hours, stretches into days. To the public, it looks like bureaucracy. To those inside, it feels like a pause button has been pressed on truth itself. 3. The noise behind the silence. By October 5th, amateur communities were restless. Threads exploded on Twitter, Reddit, and Discord. Where are the images? Some users pointed out that NASA's public servers showed unusual traffic patterns, delayed timestamp pings, incomplete downlink reports, and longer than average telemetry bursts. Others dug into ESA's ExoMars logs, discovering that the TGO had transmitted its observation data twice, on separate channels, an unusual redundancy normally reserved for sensitive targets. At the same time, inside NASA's Jet Propulsion Laboratory, a quiet conversation was happening in a secure conference room. According to one engineer, who later spoke anonymously to Skynet magazine, the HiRISE data packets had arrived early in the morning of October 4th. But when the team began assembling the frames, something looked off. We were seeing streaks, multiple, moving objects, and a kind of halo effect that didn't line up with standard motion blur. Someone said it looked like gas jets, but not in the direction you'd expect from solar radiation pressure. The angles were wrong. That was when the review order was given. For bureaucracy or something else. Officially, the reason for the delay was administrative. NASA, at that time, was experiencing a funding bottleneck. Certain data processing contracts had been suspended due to budget gridlocks. The release teams were understaffed, working reduced hours. That explanation sounded plausible, until the European Space Agency also went silent. ESA's Mars Express operates under a different budget structure, unaffected by American politics. Its imaging data, stored on European servers, usually flows freely. Yet this time, nothing. When asked, an ESA spokesperson gave a brief statement to the press. The data from the October 3rd observation is being analyzed collaboratively. Preliminary findings require verification before public release. Verification of what? No one said. The words, collaboratively, and preliminary findings, were enough to send speculation into overdrive. 5. The Whisper Network. Inside private astronomy forums, whispers spread. A few independent contractors, Data processors, software engineers, postdocs claimed they had seen portions of the uncalibrated feed before it was pulled offline. According to one of them, the images didn't show a single object. They showed three luminous points, all moving in near-perfect formation, with faint ionized trails connecting them, like filaments or tethers. One researcher described it in a message later deleted. "It's not a comet. It looks coherent, structured, like something maintaining formation." Soon after, that same researcher's account disappeared from the forum. The ghost of Schmaus. Meanwhile, Simeon Schmaus, the German astrophotographer who had processed the October 1st Perseverance images, hadn't posted anything new. His previous post, suggesting that 3I/Atlas's trajectory deviated slightly from predictions, had gone viral in niche science circles. Then, one evening, his followers noticed something. His ex-Twitter account had been wiped. His GitHub repository, containing his image processing scripts, was gone. The link redirected to a blank page. No explanation. No farewell post. Just silence. In the absence of facts, people began filling the void with stories. Some said NASA had contacted him privately. Others said he'd been harassed by skeptics. A few believed something darker, that he'd found something he wasn't supposed to. 7. Inside the blackout. At 2:16 Universal Time Coordinated on October 6, NASA's Deep Space Network recorded a burst of encrypted transmission from the Trace Gas Orbiter, a routine uplink session that lasted 34 minutes. But an internal log line marked the transmission as Priority Relay, Interagency Hold. Normally, scientific data is classified as open. The only reason to mark it as hold is if it's being reviewed under defense-level protocols, something that hasn't happened since 2009, when Mars Odyssey picked up unexplained atmospheric emissions later identified as sensor noise. Whatever the orbiters had captured, it was enough to move the file into a restricted pipeline. 8. The theories. By the end of the week, the scientific community had fractured into two camps. The first believed the blackout was entirely procedural, a combination of bureaucratic delay, underfunding, and caution. They argued that calibration of moving targets was complex, especially at such extreme distances. The second camp, smaller, but louder, believed something unprecedented had been detected. They pointed to the timing, the green flash, the multiple streaks, the perfect alignment with Mars's orbiters. And now, the silence. One journalist from Skybound Review wrote, "When space agencies go quiet together, it's never about paperwork. It's about control." 9. The countdown. As of October 7th, 3I/Atlas was already moving closer to the Sun, its brightness increasing. By late October, it would pass behind the solar glare, vanishing from view until December. If the data wasn't released before then, no independent verification would be possible. And so the world waited, scientists, amateurs, and dreamers alike, watching for a flicker in the darkness of official channels. Stephen Burns refreshed NASA's raw image feed every hour. Nothing. Just silence. The kind that hums louder than noise. Somewhere between Mars and the Sun, 3I/Atlas was still moving, fast, deliberate, silent. And somewhere on Earth, the people who had seen what it really looked like were deciding whether the world was ready to know. The WOW signal bombshell. Silence, it seems, has a memory. The same kind of silence that followed the discovery of the WOW signal in 1977, that fleeting, unexplained whisper from deep space, was now echoing again, 48 years later. Only this time, it was not in radio static. It was on Mars. 1. 1977, the night of the signal. August 15, 1977. Ohio State University's Big Ear Radio Observatory, near Delaware, Ohio. It was just past 11 p.m. when Jerry R. Emin, a volunteer astronomer, began scanning through freshly printed computer readouts, pages of dense alphanumeric strings, each representing slices of radio frequencies captured from the constellation Sagittarius. Rows of letters and numbers meant nothing to most people. To Emin, they were music. Then he saw it. A perfect spike, far beyond background noise, lasting 72 seconds, the maximum time the Big Ear telescope could listen to a single patch of sky before Earth's rotation moved it away. Emin circled the code in red pen and scribbled one word in the margin. Wow! The name stuck. 2. The lost coordinates. For decades, astronomers tried to find a source. The signal came from near the Chi Sagittarii star group, roughly in the direction of the galactic plane, but the telescope's design meant the position was ambiguous. It could have come from one of two symmetrical spots in the sky. No repeat signal was ever found. Some blamed natural phenomena, like hydrogen emissions or passing comets. Others whispered about artificial origin, a probe, a message, something directed. But as time passed, the WOW signal became a historical footnote, a curiosity from an era when humanity was still learning to listen. 3. 2025, the recalibration. Fast forward to October 2025. At the SETI Institute in Mountain View, California, astrophysicist Dr. Lena Korovin sat in front of her workstation, cross-referencing 3I/Atlas's current trajectory with old interstellar data sets. Her task was simple on paper: determine whether the object's motion matched any known solar or interstellar streams. It didn't. Then, as she began backtracking its path, simulating where it might have come from, centuries or millennia ago, she noticed something strange. When projected backward in time, 3I/Atlas's inbound trajectory passed directly through the same region of sky from which the WOW signal had been received. At first, she thought it was coincidence. Then she checked again, this time using 3 different solar reference frames. The alignment persisted. Within 0.3 degrees of the WOW signal's original coordinate uncertainty ellipse. 4. The discovery. Korovin's screen glowed with simulation data. 3I/Atlas was inbound at an angle of 59 degrees to the ecliptic plane, moving at 61 kilometers per second relative to Mars. Too fast to be captured by solar gravity, yet too controlled to be random. Its hyperbolic excess velocity, 26.4 kilometers per second, was nearly identical to that of Oumuamua, 1I/2017 U1, the first known interstellar visitor, but its light curve showed no rotation. It wasn't tumbling. Something was stabilizing it. At 2:46 a.m., she ran the trajectory overlay again, adding the 1977 WOW signal's declination and right ascension bands. The intersection lit up in green. She sat back in silence. For a few seconds she just stared, the blue lines of the past crossing the red path of the present. 5. The meeting. Later that morning, Korovin joined a secure video call with NASA's Planetary Defense Coordination Office and ESA's Near-Earth Object Program. "Your model is interesting," one of the senior analysts said. "But correlation isn't causation. We've had dozens of false alignments before." "I know," she replied. "But look at the time constants. The WOW signal source direction, 1977 RA 19 hours 22 minutes, dec minus 27 degrees. 3I/Atlas's inbound line matches within 0.29 degrees. That's within error margins. The same galactic latitude. The same orientation. It's not a random hit." There was silence on the other end. Another voice, deeper, American accent, broke it. "Are you implying the WOW signal wasn't a broadcast, but a trajectory marker?" Lena hesitated. "I'm saying it might not have been a transmission at all. Maybe it was telemetry. 6. The past in the present. The theory was radical, that what the Big Ear heard in 1977 wasn't a message but a ping, a navigational beacon, an automated burst from something moving through interstellar space, briefly aimed toward Earth as it passed the inner system. And now, nearly 50 years later, an object following that same vector had appeared, near Mars, flashing once, then vanishing behind the Sun. If that was coincidence, it was the strangest one in the history of astronomy. 7. The leak. 2 days later, an anonymous upload appeared on Astronet, a closed network used by professionals to exchange large data files. The file was titled wow_revisited_final_cal_r2025.inc. Its checksum matched NASA's internal data encryption format. Inside, compressed into a single stream, was a spectral analysis of the 1977 WOW signal, reprocessed using modern algorithms. Hidden in the noise was a secondary frequency, one never noticed before, a narrow band spike precisely 1420.4058 MHz, identical to hydrogen's rest frequency, but modulated with a 3.2 Hz periodic beat. 8. The realization. By October 10th, the story was already spreading across private astrophysics channels. SETI veterans began to whisper that maybe the WOW signal had never ended, that it was part of something cyclical, returning not as a transmission, but as a presence. Dr. Korovin stared at the last slide in her presentation. It showed the WOW signal's coordinate patch overlaid with the reconstructed path of 3I/Atlas, the two crossing like a signature written across time. At the bottom, she had typed 3 words. It came back. 9. The silence returns. That night, she tried to upload her findings to NASA's open access preprint server. The file was rejected. Then her access credentials were revoked. Her last email to a colleague read, "They told me to stop. They said the data is under joint international review. But it's already out there. Someone leaked it. So if anything happens, keep looking at Sagittarius." The message was timestamped October 11th, 2025, 1:12 Universal Time Coordinated. She never sent another. 10. Echoes of a signal. Somewhere in the void between Mars and the Sun, 3I/Atlas continued its silent descent, turning, or perhaps adjusting, ever so slightly. The Perseverance rover's cameras, still scanning the thin Martian skies, captured nothing unusual. But deep within archived telemetry from the Trace Gas Orbiter, a faint, repeating pulse continued to appear once every 72 seconds, the same duration as the WOW signal. This time, it wasn't coming from a distant star. It was coming from Mars. Chapter 4. Contact denied. For the first time in decades, NASA and ESA were united, not by discovery, but by silence. It wasn't a collaboration. It was containment. 1. The meeting that never happened. October 12, 2025. Darmstadt, Germany, ESA Operations Center, ESOC. A cold rain fell over the complex, flattening the flags outside the main building. Inside, the lights in the Europa room burned long past midnight. Around the oval table sat 12 people, 8 men, 4 women, representing NASA, ESA, and notably, 2 unmarked delegates from the United States Space Command. There were no name tags. Phones were not allowed. Every notepad was numbered. The meeting was logged internally under a coded label. E13/Merisat, Tempest/Restricted Coordination. No public record of that title exists. 2. The briefing. The presentation began with a projection of the Trace Gas Orbiter's latest data, specifically, an unfiltered spectrogram from Sol 1849, captured near Mars' equatorial orbit. The technician controlling the feed zoomed in on a faint band. At first glance, it looked like noise, a soft, rhythmic flicker across the baseline. Then he amplified it. Every 72 seconds, the same narrow spike appeared at 1420.4058 MHz. Hydrogen line, someone murmured. Natural, another said. But then, the technician increased the contrast, and within the pattern emerged a secondary modulation, 3 short pulses, 1 long, 3 short again. SOS. A deliberate structure. The room fell silent. 3. The denial. The man at the head of the table, Dr. Gregory Vaughn, director of NASA's Deep Space Communications Division, finally spoke. "This doesn't leave this room," he said. "The media is already speculating about connections between Atlas and the WOW signal. We cannot feel that. But if the signal's real," began Dr. Korovin, appearing via secure video link from California. "It's interference," Vaughn interrupted coldly. "Solar reflection, local harmonic telemetry feedback. I don't care what model you use. Officially, this doesn't exist." "Then why are we meeting about it?" someone whispered. Vaughn ignored the question. He pressed the key, and the projector displayed a memo, dated October 10th, with the NASA and ESA logos side by side. Joint Directive 4517A. Effective immediately, all Mars orbital data containing anomalous narrowband emissions are classified under the International Deep Space Security Protocol, IDSSB. Distribution beyond Tier 2 personnel is prohibited. In simpler terms, no one outside this room was allowed to know. 4. The signal that wouldn't die. Back at the Madrid Deep Space Network, engineers began implementing new filters to block the suspicious frequency. They called it routine noise reduction. But the signal didn't vanish. It shifted. Every time they masked 1420.4058 MHz, it reappeared 0.003 MHz higher, as if responding. When the engineers stopped transmitting, the spike faded, then returned once contact with Mars resumed. It was following their link. An email exchange between DSN engineers later leaked to Science Insider. "We're not picking up static, it's adaptive. Like something listening to our own transmission pattern. If that's true, it's not a reflection. It's interaction." Hours later, both engineers' accounts were deactivated. 5. Inside NASA's silence. Meanwhile, in Pasadena, inside JPL's Building 180, home of the Mission Control Operations Center, the atmosphere turned cold and bureaucratic. All Mars data channels were rerouted through a new proxy node, DSC Gateway, accessible only to senior analysts. External researchers suddenly found their credentials expired. When the Perseverance rover's data portal updated on October 13th, amateur astrophotographer Stephen Burns noticed something unusual. All recent raw frames had been replaced with identical duplicates from the previous sol. The timestamps didn't match the sun's position. The sky geometry was off. The data had been rewritten. 6. The disappearing scientists. On October 15th, Dr. Lena Korovin tried to join a follow-up meeting via secure link. The system returned a message. "User not recognized." 2 days later, her office at SETI was cleared out. Her computer was replaced with new hardware. No one at the institute would comment. Her closest colleague, Dr. Samir Qureshi, received a one-line text before her disappearance. "If they ask, tell them it was never a signal. Tell them it was a mirror." No one ever saw her again. 7. The mirror theory. The word mirror began circulating quietly among researchers still in contact through encrypted channels. The idea was chillingly simple. What if 3I/Atlas wasn't transmitting a message, but reflecting one? The 72-second hydrogen line pulses might not originate from the object at all. They might be echoes of something else, somewhere deeper, bouncing through it. An object acting as a relay, or worse, a beacon. When the HiRISE camera on Mars Reconnaissance Orbiter finally resumed imaging on October 16th, one frame slipped through before the automatic filters applied. It showed a faint, luminous arc over Mars's southern horizon, like a small crescent of light, moving independently of the stars. The image vanished from the server minutes later. 8. The internal leak. At 3:21 Universal Time Coordinated, October 17th, a new file appeared on the dark web, posted under the pseudonym Red Echo. It contained what appeared to be an internal transcript from the ESA-NASA meeting in Darmstadt. The authenticity could never be proven, but one section stood out. Vaughn, if it's artificial, we can't confirm it without creating panic. ESA delegate. And if it's a response to the WOW signal? Vaughn, then contact has already been made. Decades ago. The file ended there. Within hours, Red Echo's account disappeared. 9. The last transmission. October 19th, 2025. The Trace Gas Orbiter transmitted a final batch of uncompressed telemetry before entering safe mode. Inside that data, engineers later found a strange artifact, a repeating sequence of binary tones embedded in the background radiation. When converted into visual format, it resembled a grid, rows and columns of faint dots, interrupted by a single diagonal line. At first, it looked random. Then someone realized it wasn't noise. It was a map. A map pointing directly toward the inner solar system. Toward Earth. 10. Official denial. 2 days later, NASA released a short statement. No credible evidence of artificial signals from Mars or interstellar sources has been detected. Recent anomalies were caused by telemetry interference during solar conjunction. ESA echoed the message word for word. The agencies had spoken. The case was closed. But deep inside the Canberra Deep Space Network, the engineers monitoring residual Mars data noticed something the public would never see. At 1420.4058 MHz, the faint 72-second pulse was still there, weaker, distorted, but persistent. And this time, the frequency modulation had changed. It was no longer SOS. It was something new. 3 pulses. A pause. Then 2. 3 to 2. Or perhaps. Chapter 5. Echoes through the void. When the official channels went silent, the world forgot. But not everyone moved on. 1. The off-grid network. 3 weeks after NASA's final statement, a small encrypted server called Parallax went live. It wasn't part of any institution. No domain, no press releases. Just an anonymous invitation sent to a handful of researchers across the globe. If you still hear it, join us. Among the first to log in were names the public hadn't heard in weeks. Stephen Burns, the astrophotographer who started it all, Dr. Samir Qureshi from SETI, and a quiet account under the alias Naktathan, the night monkey, who had first noticed multiple objects near Mars. Parallax wasn't built to discuss theories. It was designed to listen. Burns had assembled something remarkable, a network of amateur radio telescopes, backyard dishes, decommissioned antennas, all synchronized through atomic clock signals. Their goal was simple. If NASA had stopped listening, they would start again. 2. The return. November 23, 2025. At 3:42 Universal Time Coordinated, the 3I/Atlas object emerged from behind the Sun. For weeks, the world's telescopes had been blind to it, hidden in solar glare. But now, as it swung back into visibility, Parallax's instruments locked on. The first signal came faint, almost buried in noise, a low, rhythmic pulse at 1420.4058 MHz, the same hydrogen frequency as before. But something was different. The interval had changed. No longer 72 seconds. Now it pulsed every 320 seconds, a pattern too deliberate to ignore. 3, 2, 3, the code that wasn't a code. Dr. Qureshi began cross-referencing the new signal pattern with archival WOW signal data from 1977. The spacing, he realized, wasn't random. It matched the Earth-Mars communication delay at that exact distance during the October 3rd flyby. 3 to 2 wasn't a message. It was a reply timing, like a ping echoing back through the void. Something had listened, waited, and answered, exactly as long as light would take to travel between planets. "It's not sending data," Burns whispered during a late-night session. "It's mirroring us. Learning how to talk." They ran an experiment. At 4:15 Universal Time Coordinated, the Parallax Network transmitted a narrow band pulse toward the same frequency, a simple binary sequence spelling HI. 5 minutes later, 3 minutes, 20 seconds exactly, the same pattern came back. Reversed. 4. The reversal. At first, they thought it was a reflection, a form of radio echo off the solar wind. But natural reflections distort. They don't invert. The returning signal wasn't a bounce, it was a reconstruction, bit by bit, like something rebuilding the message on its end and sending it back with deliberate precision. Then Burns noticed something else. Within the returning pulse, embedded at faint amplitude, was another layer of data, a modulation too subtle for the human ear but visible in the Fourier transform. A repeating curve. Not random. A shape. He increased the contrast until the pattern became visible, a waveform resembling an orbital arc. The curvature matched Mars' orbit, and a smaller, intersecting path that ended at Earth. 5. The final transmission. December 1, 2025. The Parallax team initiated what would become their final experiment. They decided to transmit one last signal, a test that, if answered, would confirm intent beyond doubt. They encoded a set of coordinates, the location of the Arecibo Observatory, long decommissioned after its collapse, but still a symbol of first contact. The pulse went out at exactly 2 o'clock Universal Time Coordinated. 5 minutes later, the reply arrived. This time, it wasn't just the same signal. It carried a signature, a longer series of pulses, rising and falling like a melody written in binary. When decoded, the pattern formed 3 simple peaks and 2 valleys, 3 to 2 again, but this time overlaid with a subtle drift downward, a Doppler shift consistent with something accelerating away from the inner solar system. 3I/Atlas was leaving. And it had answered. 6. The collapse. Within 48 hours, Parallax's servers were breached. All logs deleted. All backups wiped. Stefan Burns vanished from social media. Dr. Qureshi's lab access was revoked. The user, Naktafin, deleted their profile, leaving only a final message. It learned the interval. Next time, it won't need the echo. 2 days later, amateur astronomers tracking Atlas noticed its coma dimming, not gradually, but in discrete steps, as though the object were shutting down layer by layer. By mid-December, it was gone, not disintegrated, not lost in glare. Gone. Trajectory data from the European Southern Observatory showed a sudden, unexplained acceleration away from the Sun. No natural outgassing could explain the vector. 7. The aftermath. Officially, 3I/Atlas remains catalogued as an interstellar comet of unknown composition. Its recorded albedo, spectral profile, and residual velocity all fall outside known parameters, but no further statements were made. The world moved on. News feeds turned to other stories. But among the scattered remnants of Parallax, a few researchers kept one fragment, a small, corrupted audio file believed to contain part of the final transmission. When slowed down 10,000 times and filtered for low-frequency harmonics, the file revealed a deep, almost human tone, 6 syllables long, whispering beneath the static. It wasn't clear. It wasn't language. But one word stood out to those who heard it. Repeat. 8. Epilogue. Somewhere, between the stars, an object drifts outward. Cold. Silent. But not dead. Every 320 seconds, it releases a faint pulse into the dark. A heartbeat on the hydrogen line. Maybe it's waiting for us to speak again. Maybe it's still listening. Or maybe, just maybe, it's already found someone else to answer. And this signal we thought was ours was never meant for us. End.